Afternoon, everyone. I'm Sharik, Technical Account Manager for AWS. And alongside me is Rajashree. Rajashree, I'll let you introduce yourself.
Hello, everyone. Sorry I couldn't be in person this time. I'm Rajashree, and I work as a staff DevOps engineer at Sharethrough, and I have an 8 years of experience as a DevOps engineer, and I mainly take care of automating and having a scalable infrastructure. So yeah, nice to meet you all.
Thank you, Raja. So today we are going to discuss Sharethrough's adoption for Graviton and Spot, how they were successfully able to adopt it, leveraging native AWS services like ECS Capacity Provider and Lambda. So before I start, just want to have a quick check. How many of you are aware about ECS or EKS by any chance? Used it, worked it, pretty much. Perfect. So relevant audience. So what is Sharethrough? Or let's start with what we do. Sharethrough is a omni-channel ad exchange company, which pretty much connecting like publishers to advertisers, pretty much across all the major demand types like video, native, and display. So let's say this way. I mean, if you go to your website and there are some ads which are popping out, Sharethrough is probably somewhere behind it. So similar to Amazon Prime, we are seeing the videos, or in the videos there are advertisements coming. So there is an ad exchange which is helping coordinating these ads. So Sharethrough is one of those platforms. The scale, if we have to talk about, they operate at around 2 million QPS queries per second. They are across 4 regions in AWS. And yeah, we have been AWS partner since 2011. And they pretty much support 200 plus countries. So this 2 million QPS, this is pretty large scale. So, I mean, let's say this way, to carry this scale, you need a similar compute complementing it. And that's where the need of Graviton and Spot is pretty critical. I mean, both of those are something which are blend of cost and performance together. So that's what we are targeting here. How can we achieve this? And now when we are saying the successful adoption, let's talk on numbers. It is more than 99% of total infrastructure usage, they are using Spot. And on Graviton, it's more than 90% adoption of Graviton, of the total infrastructure. So that's what we are going to discuss here. So let's take a step back. How were they using it before? This is what we did last year. But now, how were they managing this piece before? So the answer is there was a third party. There are still third party providers which do this job for multiple customers. So they have been utilizing this for last 5 years, I think 2017 to 2022, start of 2023. The job is they integrated with ECS, and then they will facilitate providing the Spot infrastructure for the customer from the AWS cloud. The basic difference or the primary feature what they work is how to seamlessly move between Spot and on demand. So if there is a, let's say the Spot capacity is getting peaked out, or there is on the Spot side, there is a capacity issues. Right now, with the existing AWS, I think ECS solutions, there is no default way where we can move to on demand on seamlessly. So this is something which third-party providers can provide, more like a seamless transition between Spot and on demand. So that effortless transition between the two is what they are designed for. And let's say this way, they are doing their job pretty good. Like there was no operational issues. But when we say then what pretty much motivated the transition, or what motivated the ask that we need to move to third party like a native solution? So the answer is cost. I mean, everything comes with a price tag, right? So that's where the price, the cost of using these third party solutions was pretty high. They operate in pretty much like a pay as you go model where you pay for the number of instances you use. So let's say this way. For a month, I did $100,000 of spot usage. It somehow equates to $400,000 of on-demand usage. So right now, the third-party provider, and this is pretty much same for any provider solutions we have in market, they will charge 20% of the delta between spot and on-demand. So comes to 20% of 300,000, $60,000 is what we are paying to the provider solutions just to provide a solution so that somebody can leverage spot in an optimized way. Taking a quick pause. Any questions so far on this? I think many of us know the providers. Many of us have been using multiple providers, but just want to check, are we in line? Any questions so far on this? Perfect. So now, the cost being a dominating factor, asked for the options like how can we accomplish the same thing, same goals by leveraging the native AWS services. And that's where the thing came is, if you're using ECS, there is a ECS capacity providers, which do more or less the same thing. If I'm doing EKS, then there is a cluster autoscaler and a Carpenter. Carpenter is out-of-box solution providing the exactly same thing. When I'm saying exactly, pretty much the same thing which we have targeted in ECS. Now, before we dive deep into this architecture, how we did it right now, I would like to explain state it very clearly that with the default out-of-box capacity provider solution, we can still use on-demand and spot in conjunction. Remember our baseline, what we were targeting. We can use on-demand and spot. The issue was how to seamlessly move from one to other. Like if you're using spot, how can we transition back to on-demand on the fly without any outage or impact? Right now with the default options, we can put it in configuration and we can provide weights or a ratio where we can say that, okay, for 2 on-demand instance, give me 8 spot instances. Kind of a weight, whatever we choose. But the problem is that is everything in the configuration. That is not dynamic. We cannot do it on the fly. If we do it on the fly, that will need a whole deployment to be re-triggered, which pretty much is not acceptable in many production environments. So what we came up with a solution was, I don't know how laser works, but yeah, we came up with 2 capacity providers in each AZ. This is an example of US East 1. So there are 5 AZs. There are 6. The Sharethrough is using 5. So we came up with the 2 capacity providers in each AZ, 1 spot, 1 on demand. And then each capacity provider is further attached to an auto-scaling group. The idea here was, the reason of putting it to 5 was twofold. One, we wanted to make sure that we are utilizing spot capacity to the fullest. And spot, as we know, is per AZ, spot for pools. So we want to make sure that if there is a impact or a capacity impact on one spot pool, that should not be impacting the entire ACS cluster. It should be only modularized or targeted or narrowed down to that AZ. And then the second one, we are using network load balancer in this scenario. Again, for the cost. Network load balancer, if we are not using, if we are aware about the load balancing piece, if we are not using path-based routing and our workloads permits, network load balancers are around 20 to 30% cheaper in cost as compared to application load balancers. So that's what prompted using of NLBs in this scenario. And NLBs come up with a one hard quota limit that there can be maximum of 1,000 instances per target group per AZ. So which apparently worked in our favor in this case, because now we have an option to scale further. So with the NLB, we used 5 NLBs in this case, 1 NLB per AZ. That's a fixed IP. But what that means is now I can scale per AZ. So we are going to discuss this further, but just for the reference right now, 2 capacity providers per AZ each capacity provider attached to a auto-scaling group, spot capacity provider as a primary, which will be always active, on-demand capacity provider as a standby, which, as we said, will be used only when needed. And then there is a Lambda, which will be doing an actual trigger between the two. We are going to discuss the Lambda in the next slide, but again, taking a quick pause. Any questions so far? Yes.
I have a question about the NLP. So you say you have one per AZ.
That's right.
Is that for all the services or each individual service on the EPS of the ECS task?
I mean, this specific workload is a single service. So definitely, yes, it's one single service in this scenario. And that's why I said if there are multiple services and we are using path-based routing, the scenario would differ. So now let's discuss the Lambda, which is at the end. Remember, in this solution, we are using two different Lambdas. This Lambda is primarily focused on the cost side, which is Spot. There would be another one for the performance, which is more on Graviton centric. But right now, let's talk about the first Lambda. So this Lambda solution, which we engineered, was more about switching between on-demand instances if when needed. As we said, we have two discrete capacity providers, Spot and on-demand. The Lambda facilitated the automation of transitioning between the Spot to on-demand as on when the Spot capacity was not available. How we did that? The follow-up slide will explain that. But then there was additional check. What when the Spot capacity is again back? How should we fall back to the Spot? Because that's another goal. So that was another piece incorporated. And again, yes, the idea was we should be running on Spot as much as possible. So that's the basic flow. The way we did was we set up an alarms on the auto scaling group. On the auto scaling group side, if we see there, we pretty much set the alarms to monitor it every 20 minutes, that if the Spot capacity is not available for 20 minutes at any point. ECS, EKS, they work on the same principle of desired capacity and the running capacity. Depending upon our workload, the desired capacity is something which cluster sets. If our desired capacity is more than the existing running capacity for more than 20 minutes, that means in EKS scenario, cluster autoscaler or carpenter. In ECS scenario, capacity provider is not able to fulfill the request. And remember, capacity provider cannot automatically switch between two. It will keep on, there is no timeout limit. It will keep on trying for the capacity until accomplished. So what that means is, if for 20 minutes, and again, it's the time we have to choose depending upon our workload, that if capacity provider is not able to meet the capacity in 20 minutes, definitely there is some issue. And that's when the Lambda gets triggered. The first Lambda gets triggered, it will fail over, it will start building up on the on-demand capacity provider. It will start with the delta, whatever is the missing delta between desired and the running instances. And then gradually it will keep on adding unless the desired capacity and the running capacities are same. And then, so that's what I think the third point said. So as long as the sufficient Spot instances and the on-demand instances are more than 0, the alarm will be getting triggered. End of the day, the alarm will only stop when the Spot side desired, Spot capacity provider desired capacity and running capacity are same. So if that means it takes 12 hours, well, the Spot capacity was not available for 12 hours. At least it did the seamless transition. And then once Spot capacity is back, it will gradually take down the delta from the on-demand, start building up on the Spot again, and finally the alarm will be clear when the on-demand instance count is set back to 0. That means my Spot is again back in the production environment. Taking a quick pause. Any questions on this? Yes.
When we transition from on-demand to Spot, will there be any data loss or any delay or something?
No. So let's say this way, whatever we are doing, transitioning back from Spot to on-demand, we are assuming it's a microservice architecture. stateless architecture. Whatever is the cluster or whatever it would have been the scenario when, let's say, we are scaling up or scaling down, it's exactly the same thing, scaling up and scaling down. It's just that now we are choosing where to scale up and where to scale down. But we assume the data loss is something which, when we are building a cluster and we are adding a scaling mechanism, this is by default there. So this is for the stateless workloads. As long as your workloads can run on cluster solution, there should not be any data loss.
If I read that correctly, when you scale up, you become Spot instances, and the on-demand instances will be terminated as the Spot instances, like on the backend Spot workload is the.
So when I scale up, it will anyways try to launch Spot instances. If Spot is not available, it will launch on-demand instances. But that will not re-trigger any new deployment. That will not affect the existing workload. My existing workload will be running. So let's say if I'm running with, so in this scenario, we go up to 5,000 instances at a time. So if I'm running with the 4,000 instances of Spot in a region, one region, and then there is additional capacity of ask of 1,000 more instances, it will, in the normal scenario, or with the existing default out of the box solution scenario, it would have redeployed the entire 4,000 instances and the new deployment would have triggered with the 5,000 instances. That should not happen now. It will only bring up 1,000 more new instances to match the workload, only the delta. And that's what pretty much the existing third-party provider solutions are also providing. They are giving the delta. They are pretty much doing the same thing. Like they are doing what they are built for. So this specific solution. Any questions?
Yeah, thank you for presenting the solution. One question, AWS auto-scaling groups support both Spot and on-demand right now.
Yep.
Why you have to create two auto-scaling groups in your solution?
So making sure you are saying auto-scaling groups or capacity providers?
Auto-scaling.
So
Auto-scaling.
that is because ECS cannot directly attach to auto-scaling groups. It has to attach via capacity providers. It's like the cluster capacity needs to be provided via capacity provider, which further would be attached to auto-scaling group. And capacity provider can be only linked to one auto-scaling group at a time. So it's not a, you very rightly said, auto-scaling group, we can use priority optimize, capacity optimize, Spot, on-demand ratio, everything. But ECS cannot be directly linked with the ASG.
You mentioned that you have NOBs on every single availability zone. How are you combining all those together?
Yep. So I was waiting for someone to ask that. So yes, that as much as we say, and again, this is not a very ideal way of saying it, but yes, we leverage a Route 53 as a load balancer. The first thing Route 53 says, it is not a load balancer. Very well clear, agreed. But in this case, it works for us. The way we are doing is, we have 5 NLBs, they have fixed IPs. We use it as a alias or a CNAME in the Route 53. They are further, whenever there is any query or anyone hitting the request on the Route 53 endpoint, it is weighted routing. Everybody is getting equal share, 20%. It gets routed to the specific AZ, which is a working solution for us as of now.
So is it basically calls?
Sorry?
Let's say you have clients that come in from different regions, or if they closer to one availability zones than another.
I mean, yeah, so this is a regional service. As we said, we are spread across multiple regions. So this specific region anyways hits the target from North America. As we said, US East 1. This is catering to North America region as of now. So that's why it works. Yeah.
So 2 questions. The 20-minute time frame, it's adjustable downward, right?
Yeah, it's adjustable. It's something we just did a hit and try where this was the number
What
we
you
think
use, that's
worked
fine.
for us.
So in a perfect storm, you've been hit with a lot of volume. Spot instances are unavailable.
Sorry,
Spot instances are unavailable. Now you start scaling up to your on demand. Do you see it? You have to see a performance hit, right? You
why?
can't. You have to see a performance hit. Do you not?
Why should we see performance hit? I'm trying to understand.
Because you're losing instances and adding instances, and you have a high volume.
I mean, if let's say this way, if we are not losing instances, yes, if they are being terminated
Right.
at that same time, we would be having an equal amount of instances getting scaled up in the on-demand. Again, let's say this way, if we are saying there is some region going down, impact where the whole AZ went down, yes, I would see a performance hit.
That's a different story, right? So you
But-
have 10, make it easy. You have 10 spot instances. Now they go 10, 9, 8, and you're starting to scale up with on-demand instances, right? Because you're going to use
That's
that
right.
capacity, and you're getting hit with high volume. You must see a latency.
I mean, that's what I'm saying. So
Yeah.
let's say this way, we have been running for 1 year. We haven't seen any latency so far, and that included Black Friday, which is the peak time. So when we are saying this 20 minutes, and again, this was the number which it has to be, because we have to be very mindful. How should we do, how aggressive should we scale in versus scale out? The both numbers should match up, right? Aggressive scaling should help, step scaling or not. Remember this thing, there is, every workload has their own expectation of like how fast they are going to see a ramp up or not down. There is a ECS cluster metrics, which is controlling the scaling feature here. Let's like, in this case, it is the request thresholds, like how many QPS or how many requests are hitting the load balancer, which is the primary monitoring metrics. So let's say if there is 1 million TPS, that it is not that from 1 million, it will abruptly go to 2 million. There would be a scaling pattern, right? Where it will be scaling gradually. And that's where it will be gradually increasing. Yes, if we say that Spot is completely unavailable, still there is a time between 10, 15 minutes where the on-demand is always there. We are losing on money, but gradually we are building up. What I'm trying to say is Spot should not be the limiting factor on the performance impact. The limiting factor should be slow scale up, which is like how fast are we monitoring and further scaling up. And there is, I think next slide or the next to next slide, there is a mention that how this thing, and this was a pleasant surprise, which we see, was that the provisioning time of how fast can we provision instances. We had a metric where we identified that during using a previous solution or a third-party solution, it took 5 minutes to provision an instance after the first scaling instruction was sent to ECS, or ECS like got an instruction to scale up. Now that is reduced to 3 minutes, just because reducing the hops. Previously, the API was there, ECS was sending an API to the third-party solution, it was scaling up, and then it was going back to AWS. Now we have reduced the latency hops. So from 5 minutes, we reduced to 3 minutes, 40% performance improvement. So, I mean, from let's probably let's wait till the end of the slides. But yes, that thing is being mentioned.
This works well for microservices, right?
That's right.
If you have a monolithic application, your all bets are off, right?
Yep.
Yeah. Right. Thank you.
Any more questions? Perfect. So that covered the previous phase of the cost side of Lambda. Now comes another challenge. Okay, we have our solution working. Now the second piece comes is how should we identify or use the right amount of instances? Now in this scenario, another challenge we faced was if we used priority optimized or a cost optimized architecture solution. So in those ones, the default options, like let's say if I'm doing a cost optimized in the auto scaling group, as we said, there are multiple options. So it will always choose the cheapest Spot instance which is available, matching my criteria. But that probably is not always the best instance which I need. In the clustered scenario, there is always a catch that if I'm clubbing or bin packing multiple instances in a single instance, let's say using 16x large instance, that works well to compress multiple applications instead of using 8 2x instances. So, but the price optimized will always look for the cheaper instance. So if I have, let's say, 8 containers, which probably work with a 2x large instance each, in the price capacity optimized scenario, it will choose 8 EC2 instances of 2x large. But probably the application with the whole interprocess communication and IPC workload between the workloads, a 16x large instance would have been much better solution. So in that scenario, the way we did was we used the priority capacity optimized approach. In that approach, we further leveraged another Lambda, which was running every day. It was using an ECS spot capacity history to list down the instances, creating our own bucket of instances, which were matching our workload requirements and were cheaper. And then depending upon those, what we did was a Lambda was updating an auto-scaling group every day, where it was using the priority of 40 instances. 40 is the reason because ASG supports maximum of 40 instances per priority group. So we leveraged that, and we were able to pretty much leverage, they all were Graviton instances. And we were able to update our auto-scaling groups pretty much to the latest, where we know that the capacity for these instances, at least for last 7 days, were well and good. The price was right, and this serves our workload requirements. So that, like, after testing multiple capacity optimized, priority optimized, and price optimized, end of the day, the specific Lambda did work well for us. So basically 2 Lambdas along with the capacity provider did the job. Final results, a more than $1 million savings yearly. It was by saving on the spot instances, and that is from the last year data. This year, business has grown. It is pretty much more. And I'm not sure where it is stating, but there was a as I said, the deployment time reduced from 5 minutes to 3 minutes. And there was no extra billing, as we said. Is there? Yeah, the last one. The ECS coupled with seamless integrations, significant reduced provisioning times from 5 minutes to 3 minutes. That's because reducing of hop counts. And yeah, ASG was relatively simple to set up anyways. Like, it's the ASG what we are using. So that did the trick.
In the beginning of your presentation, you opened with third-party platforms that can handle similar tasks. You mentioned that typically they charge a percentage of the savings gained, let's say 20% of the $300,000, $60,000 in your scenario. Mm-hmm. How does the pricing for this service work? Is it percentage-based or?
This one you're saying? It's free. It's a AWS service, native service. There is no charge.
There's no computing charge?
You pay for Lambda.
Okay.
Which is 10 cents per million, something like that. Mm-hmm. That's it. And it's a default offering. I mean, it comes if you're using ECS, it's by default there.
You briefly also mentioned earlier that there could be some negative repercussions of reducing the alarm time. You had it set for 20 minutes. So what would be a negative impact of setting it, let's say, for 30 seconds? So we reduce the amount of time on the on-demand instances as soon as the spot becomes available.
Not for this workload, but yeah, generally also I've been working with multiple customers. So reducing the aggressive scale in is reducing the instances. Aggressively reducing the instances can further impact your performance, because what if your application is pretty fluctuating a lot? It's every 5 minutes you are seeing the peaks, and then the peaks are dropping. It is good idea to keep your application running like that if there are a lot of fluctuations. If we know our application workload trend, we know that, okay, during business hours, it peaks out, then it peaks in, then yes, wasting additional 5 minutes to scale in doesn't make sense. But every 15 minutes, if you're seeing peaks, it's better to keep instances running than to relaunch them. As I said, there is a provisioning time added also, which can further impact or give 5x errors in our scenarios.
Okay, understood. Thank you.
Yes, sir.
Previous slide where you're calculating the spot price history, were you including the spot placement score at all in that calculation to say if it's...
Yes, so we have been working with the spot teams, and that's let's say this way, we didn't need it to as of now. That was a recommendation, but as we said, existing solution or the existing script is working fine. But yes, so that's the plan going forward. At some point we will. Sure.
Was this solution published anywhere?
Sorry?
Was it published anywhere as a solution?
No, it is not, for the known reasons. But yeah, we can definitely discuss during happy hours.
Any other questions?
Do you have any, like some of the third-party vendors may produce like reporting or visualizations on, you know, kind of the number of spot instances, interruptions, all that type of stuff. Have you built any of that out with this solution?
Yeah, I think Raja can answer that better. Raja, did you hear that question?
Yeah, I did. So yeah, we do have like a lot of panels and dashboards set up in Grafana. We consume most of the CloudWatch metrics, and also we have Prometheus set up for our server, which basically, like the hotel collector, basically sends the metrics to Prometheus, and that sends the information to Grafana. So we basically have all those information which we were seeing in the third-party provider available here as well, like how many Spot instances are there and how many on-demand instances we spun up and what's the latency and how much time it's taking to basically spin that instance up. So we have all those metrics in.
Any more?
All right, then a big hand for Sharik.